All right, so as I mentioned before, there are several Maclaurin series that you have to memorize just to save time on the EP exam. It is very important, and you are going to have questions on the multiple choice section, as well as free response that involves Taylor series, Maclaurin series. So, but if you can't remember, if you can't, then you can always, derive it. And let me explain to you how. So this is the formula that you can use and should use for the Maclaurin series. Maclaurin series is actually Taylor series, but it's centered at 0. So x equals to 0. Well, let's say we want to derive the Maclaurin series for e to the x function. And if you can't remember, which is a problem, you do need to memorize. But as I said, you can derive it. So this is what you do. So start with f of 0 first. Let's find the first element, first term of this series, of this polynomial. F of 0 equals e to the 0, which is 1. So that means the value of this is 1. Now let's find f prime of 0. So f prime of x is e to the x prime is e to the x, but at x equals 0, you get e to the 0, which is 1. So the coefficient here is 1. So you have 1 plus 1 times, see this x plus, now let's see what this is. So the second derivative equals the derivative, the first derivative was e to the x, second derivative is also e to the x, and at x equals 0, you again get 1. So then that means the third element would be f double prime of 0 is 1, and then you do x squared, and then you do over 2 factorial. So you can add one more, and then that would be enough. You'll be able to see the pattern. So the third derivative is again e to the x. At 0, you get 1. So that means this is 1, but then you do x cubed over 3 factorial. Let's put them together. E to the x equals 1, because that's 1, plus 1 times x, I'm just going to put x, plus x squared over 2 factorial, plus x cubed over 3 factorial. Can you tell what's going to happen next? X to the 4th over 4 factorial, plus, can you write the general form? It's x to the nth over n factorial. Okay, so when you see e to the power of x, I want you to be able, without deriving, I want you to be able to write this whole polynomial right away. 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and so on. All right, now let's try to derive sine of x. So it's the same idea. So we need to, I'm just going to put right here, f of 0, f prime, f double prime, but then it goes x squared over 2 factorial, f triple prime, x cubed over 3 factorial, and so on. So let's start with f of 0. Sine of 0 is 0. So the first element, we can actually start creating our polynomial somewhere here on the bottom. So the first element is 0 plus, let's find f prime. F prime of 0, derivative of sine is cosine, and the cosine of 0, because you plug in 0, you get 1. So therefore, The second coefficient is 1, and then you have x next to it. Plus. Now let's find the second derivative. So the derivative of cosine is negative sine, but then you replace it with 0, and you get, well, you get 0. So that means it's 0 x squared over 2 factorial. Next. Triple derivative. Derivative of sine is cosine, but you have the negative sign, so it's negative cosine. Plug in 0, you get negative 1. So that means the next term would be negative 1 x cubed over 3 factorial. Let's find one more. F, the fourth derivative. Derivative of cosine is negative sine, but you have a negative which disappears, and you just get sine of 0, 0. So that means you get plus 0 x to the fourth over 4 factorial. Let's find one more. Fifth derivative. Derivative of sine is cosine. Plug in 0. That's 1. So we get plus 1 x to the fifth over 5 factorial. I think that's enough. So finally we get sine of x. You can express in a polynomial form, which is x minus x cubed over 3 factorial plus x to the fifth over 5 factorial. I hope you noticed it's on the bottom. You get 1 factorial, 3 factorial, 5. Can you tell what's going to happen next? And then you skip 1 because you get 0 at some point. So can you tell what's going to happen next? And it alternates the sign, negative, plus, so it's going to be negative. And then it's 3, 5, so that would be 7th over 7 factorial, and so on. So this guy is right here, very important. You're going to see it definitely on the AP exam this year. So you have to memorize again, because deriving takes so much time. So you have to remember that sine of x you can express as x minus x cubed over 3 factorial plus x to the fifth over 5 factorial, and so on. You can derive the same way you can derive tangent inverse, which you have to remember. So let me write down. So these are the most important polynomials. So 1 plus x squared over 2 factorial, x cubed over 3 factorial, and so on. Sine of x, we just derived it. Odd numbers appear here. 5 factorial, 7 factorial, and so on. Cosine, you can just derive it the same way, which I'm not going to do. You got the idea. But it's 1 minus x squared, now evens. You know what else? Easy to remember. Also alternates. Cosine and sine both. The signs alternate, but also the sine is odd function, so that's why the odd numbers appear here. And cosine is even function, so you can see even numbers only. So kind of analogous, something that helps you to memorize. There's another one, 1 over 1 minus x, also special function that you have to memorize without deriving. But this one is easy, actually. No factorials. So there's one more tangent inverse, but that doesn't appear as often as these guys. These guys you see all the time. Okay, now I want to show you a couple of examples. Example number 1, it says find a Maclaurin polynomial. Maclaurin means you consider x to be 0, x equals 0. Maclaurin polynomial of degree n for each of the following. So it says f of x equals e to the power of 2x, and it says n is 4. So I guess they want the only first four terms. So let's see. As I said, you should remember without deriving, you should be able to tell that the Maclaurin series for e to the x is 1 plus x plus polynomial, Maclaurin polynomial, x squared over 2 factorial plus x cubed over 3 factorial, and so on. Now, in this case, it's not, the exponent is not x, it's 2x. Okay, fine, then what you're going to do is you're going to replace each x with whatever they give you, 2x. That's it. So you're going to say e to the power of 2x equals 1 plus 2x plus 2x squared over 2 factorial plus 2x cubed over 3 factorial plus, you can add one more, 2x to the fourth over 4 factorial, and so on. Now, we should simplify it because that's what usually they do on multiple choice. So it's 1 plus 2x plus 4x squared over 2 factorial plus 8x cubed over 3 factorial plus 16x to the fourth over 4 factorial. Now, you might see, as your answer, you might see something like this, or sometimes they simplify even further. So for a 2 factorial is 1 times 2 is 2. 4 divided by 2 is 2, so you just get 2x squared. Next, 3 factorial is 1 times 2 times 3, which is 6. And 8 over 6 gives you 4 over, you know what, let me just do this. If I put 8 over 3 factorial and x cubed, that's okay. But if you see this, then you have to reduce it. 2 goes, so it's 4. We can put x cubed on the top over 3. And then the last one, 4 factorial, 24, so you simplify and you get 2x to the fourth over 3. Yes. So we have n is 4. So this exponent represents n, and they want only 4. So we're done. So let's see if we can do now next problem where it says write Maclaurin series for this function. And again, they want only how many? 5, I guess, because n is 4. So let's see. So this one. First, again, you want to start with the main Maclaurin series for e to the x, because that's what we have here. So we're going to do 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the fourth over 4 factorial, and so on. Now, it says 2x. It's not x. Okay, so then you're going to do, instead of x, you're going to put 2x. And we already did that, but pretend you didn't. So let's start over again. Pretend like it's a brand new problem. It's good to practice. Now they want us to multiply this result by, what do you see here? By x. Fine, so you're just going to put x times e to the power of 2x. So 1 times x is x. 2x times x is 2x squared. Then here you get 4x squared, but you're multiplying by x. So basically I'm doing this. I'm multiplying by x, each one. So I'm going to get 4x to the third over 2 factorial, and then 8x to the fourth over 3 factorial, and then 16x to the fifth over 4 factorial. Sorry, I just noticed I missed x cubed. Okay, so they want n to be equal to 4, so then that's it. Then we don't want to include these, so that's just going to be our answer. So now I want to show you, before I do the next example, so we talked about Maclaurin series and Taylor series. It looks pretty much the same. It's just now it's not centered at 0. So it's not f of 0, but it's f of, and if it's centered at x equals 5, then you start with f of 5. If it's centered at 3, you start with f of 3. So c. So c is some kind of number. And then the formula is the same. F prime of cx, oops, sorry. It's not just x, because it's centered at c, so it's x factor, x minus c. And then plus f double prime of c at x minus c squared over 2 factorial plus f triple prime c over 3 factorial and x minus c cubed, and so on. So same pattern. So now, in this problem, it says, find the Taylor polynomial of degree n centered at x equals c for each of the following. And let's say we want to work with ln of x, and it says n is 5, and so the exponent, and c is 1. So it's centered at c equals 1. So you're going to use this formula right here to express ln of x. So let's start with f of c would be, in this case, it's 1. So f of 1. What's ln of 1? ln of 1 is 0. So this element right here, the first term, is 0. We can actually start writing our new polynomial here, f of x. No, not f of x. We're dealing with ln of x equals, now, 0 plus. Now let's find f prime of 1. ln of x prime is 1